Hello, everybody. My name is Kit Pham. Joining me today is my partner, Shane O'Connor, and we'd like to thank everybody for joining us today. We are Team SES America, and we're here to talk about blank out sign connectivity over a cellular network. So before we talk about project motivation, I want to answer this important question of what a blank out sign really is. Well, it is essentially an array of LEDs held together by a metal casing that functions to display a variety of predefined messages. So, for example, no left turn, no right turn, and an incoming pedestrian. With that being said, our project motivation regarding the work around these blank out signs are twofold. First is public safety. We want to build a mechanism to be able to alert motorists and drivers on the highway for any possible lane closures, such as car accident or lane construction in real time. Second is to simplify sign changing. This is essential because currently operators and technicians are only able to change their blank out sign once they manually drive out to the test site. Our anticipated best outcome is to solve exactly that, to build a blank out sign system controller that allows these motorists to change blank out signs from any remote area, even their offices if need be. Second is for secure user authentication with certain features such as unique user roles and access. And we'd like to announce that the team has successfully achieved the anticipated best outcome. And with the achievement of the anticipated best outcome, there are a number of key milestones that were achieved during the course of this semester, and I'd like to highlight 4 of them. First is secure user authentication. Second is our cellular modem communication. Third is application deployment. And last but certainly not least, sign display and functionality. Now, I'd like to talk to you about the first of our key features, which is application security. When we were designing our application, the team tried to uphold the CIA principles of confidentiality, integrity, and availability. Integrity was upheld with schema validation and unique users. Schema validation is essentially making it so there's no invalid information being sent to the database. So say, for example, you try to enter a password of 1 + 1 = 2. We're trying to make sure that you can't do something like that. This would stop certain attacks like SQL injection. Our next measure is unique users. This makes it so there's only one instance of a user in the system. And finally, confidentiality was achieved with role-based access control, where we're essentially establishing different permission levels of the website to the users. So say, for example, a normal user could change their sign, while an admin can also change the permissions of those users in the system. And with that being said, I'd like to hand it off to Shane to talk about the rest of our key accomplishments.
Thank you, Kit. So the next key feature I'd like to talk about is the deployment of our application. We decided on deploying the application on the EC2 instance on Amazon Web Services. The EC2 instance essentially functions as a server within the cloud that you can run various applications on. In our case, we happen to run our application and our database on there. This is especially noteworthy because the AWS doesn't offer native MongoDB support as a NoSQL option. And finally, for the deployment of our application, we had to use an AWS tool to create an elastic IP to redirect all our traffic in the coming into the application. The next key feature is the cellular modem communication, and this over here is our system for doing so. So outlined in yellow here, you see the Skywire development kit, and then outlined in red is the actual modem. So the modem sends a series of GET requests on a loop and awaits the response. Once the response is received, it will pass that along to the Arduino serially, and the Arduino acts as the brains of the whole operation. The Arduino sets up, or turns on the modem, sets up the internet properties, and then passes the data along to the relays to be translated into something that the sign can understand. And all of these messages are defined by the over-the-air protocol, a table of which can be found in the program. The over-the-air protocol was developed by SES America for sending messages over the LTE network. And finally, for our key features is the sign functionality. The sign functionality consists of 3 major operations: the display message function, the relay, and the forward function. The display message function is pretty simple. It just receives the command from the application and displays whatever message is received on the sign. The relay and forward functions are a little more complicated. The forward function will receive that message on the first sign and then forward it along to the second sign. The relay function will receive that message from the application on the first sign, send a relay command to the second sign, and then the second sign will forward it along to a third sign. And this can be expanded in the future to a n number chain of signs. The relay and forward functions are done with RF communication, simply because the message that we're sending isn't very robust. So it can be done simply. Some considerations going into the future for field deployment include a network manager, so that, say, for example, RIDOT and the Mass DOT have their own separate networks of signs that they can interact with, because we don't want one company to be able to interact with the other company's signs. We would also like to have a stronger Google Maps integration so that you can simply click on a pip, get the location, the status of the sign, and whether, like, what message it is displaying at the time. And we would also like to have more in-depth fault handling, just so that you can see whether or not a sign has crashed or is off, on, etc. And finally, we would like to have transceivers on relay and forward signs, just so that we can combine two components down into one component. And we would like to thank everyone who helped make this project possible.